Everyone, so we are turned to our notes section. Please, Mr. Green, be careful when you sit down that you don't, shake the, as you call it, Android.
Yes, ma'am.
Okay. So, here we go. You guys, I need you to title this, transformations. Okay. So when you hear the word transformation, right? What comes to mind, you guys?
A transformer.
Yes, the Transformer movie, right? What else?
It's
What
2020
does it mean to transform?
to change, like from a
Okay.
girl to.
Okay.
I'm sorry, it's 2020.
That was purposeful.
It was 2020.
Watch it, dude. Watch
Yes, ma'am. Yes, ma'am.
Okay, you guys, math. You guys, so today is not going to be doing math. Okay, this is going to be a conversation that you'll have to tune into this station and listen to. Okay, or you'll just miss it. Okay, but it's not difficult, but you wouldn't know it unless I told it to you. Okay, and luckily for us, those of you who are taking the Algebra EOC in 2 weeks, this is all over it. Okay, so this could be like an easy 2, 3, or 4 points on the EOC for you guys. Okay, so I want to bring you back to our first lesson in quadratics when I talked to you about the parent function and why I called it the parent function, because this parent function, okay, all the other graphs are compared to. Okay, so I showed you that f of x equals x squared, or it means the same thing as y equals x squared. And again, f of x means the same thing as y. And I did the table of values for you when we did -2, -1, 0, 1, and 2, and we put it into the table, and then we, plotted each of the points, and that's how we got our parabola, our parent function. Okay, so not a lot of notes to take today, but the notes I tell you to write down, you need to write it down. Here we go. I need you to write down the standard form, ax squared plus bx plus c. The standard form of a quadratic. Now, what I need you to do is circle this x squared. Okay, so remember, you guys, we have an a term, a b term, and a c term in our standard form. And I want you to circle this x squared right here and put a star. Because everything around that x squared is going to transform that parent function. Right now, f of x equals x squared. Here's our parent function. Nothing has been done to it. Okay, but if you put an a value in front of it, it will transform it. Okay, so what I need, and here's the thing that I don't like about this. Where's the blue? Here's the thing that I don't like about this lesson is that there is a little bit of memorization, but I'm trying to eliminate the memorization by showing you this table right now. Okay, so everyone draw an arrow to your a term. And I want you to write the positive and negative symbol, okay? Because what did we say would happen to the parent function if this a value was negative? What did we say would happen?
It would be a frowny face.
Frowny face, thank you. Okay, so it would flip it upside down. So that's why I said put your positive and negative symbol and point it to the a value in your notes, because that's your reminder that this a value you'll either have, if it's positive, it'll be a smiley face. If it's negative, it will be a frowny face and it will flip it down. That's a transformation, okay? But this a value can also do something to it, okay? So put a little star and write fraction and whole number. Okay? Now, when I'm thinking about a fraction, I'm thinking about 1/2, right? If you take half of something, right? If you were to take, half of a sandwich, you're cutting it in half, right? you're making it smaller. You're making the portion size smaller. So you would think that if this a term was a fraction, okay, that it would make the parent function smaller, but it actually does the opposite. So for the a term, this is the first opposite you need to know. Okay, so write the word opposite. So when this a value is a fraction, it makes the parent function wider. Okay, you would think it would make it smaller and skinnier, but it actually does the opposite. Okay, so if this a value is a fraction, it makes the parent function wider. Okay, and then if it's a whole number, it actually does the opposite and makes it skinnier. So everyone write skinny. Okay? So so you don't have to memorize it. You kind of do, but here is the table to explain it. Okay? So here you have this is y equals 1/3 x squared. So if that 1/3 wasn't there, you would just have the parent function alone. But now there's an a value, okay, which is 1/3. It's a fraction, so we're going to expect that it's going to make the parent function wider. So let's take a look. If we plug 0 into the function, 1/3 times 0 squared is 0, 0. If we put 3 into the function, we get 3, 3. If we put x into the function, we get 6, 12. Okay, so this parent function became, it stayed exactly in the same position, only it made it wider. Okay, so if it's a whole number, the a value and the b value does something to it, and the c value does something to it. Okay, transforms it. Okay, so if the a value is positive, it's a smiley face. If it's negative, it flips it down. If the a value is a fraction, it makes it wider, and if it's a whole number, it makes it skinnier. So I'm going to just scroll this up so you can see an example. Okay, here you go. Okay, so here's our original f of x equals x squared, and we don't, that could say g of x, h of x, p of x, I don't care what it says, okay? We know that that means y equals x squared. X squared is the parent function, that's why we put the star above that x squared. This is the original. Now, what did we do to that original? We have a negative whole number. And look at what we have here. What did that negative 4, the a value, do to that? I want you to look at that as a parent function. What did that negative 4 do to the parent function? Well, it's a negative, so it did what? It flipped it upside down. And then it's a whole number, so it made it what? Skinnier. Do you see the original? And do you see how this is skinnier? Do we all see that? Yes? Now, here's the next example. Well, that's a positive, so it's still going to be a smiley face, right? Not changing the direction, okay? But that's a fraction. So do you see from the original, here's our parent function, how that fraction made it wider, okay? So here's a question that you might be given on the EOC. So let's take a look here, okay? What is the order, without even giving you a graph, now that you know what the a value does to the parent function, it says, what is the order from widest, you want to mention the widest first, to narrowest of the graphs of the functions, okay? So which one of these three up here would be the widest? Angela? Which one of these would be the widest? Yes, negative 1/3. Then what would be the next narrowest?
Negative.
Yes, Keith, negative x. And then what would be the skinniest of the three? The 3x. Okay? So, you know, not a lot, you're not writing hardly at all, which it doesn't take a lot of writing. Today is about, it's not math, today is about vocabulary and listening, okay, and knowing how to recognize it will be asked of you this way on the EOC, for those of you who are taking it in 2 weeks. Okay, so let me scroll this down. Okay, so now I want you to take a, Corey, what's the difference between this function and this function that you can clearly see? Yeah. Okay? So the one on the right adds 3. Okay? You guys, this is your C term. How do I know that? Because does the C term have a variable? No, the C term is always what? A whole number, and we can also refer to that as our what? Y-intercept, okay? So the C term is always going to be a whole number. So now add to your notes, to your standard form, draw an arrow pointing to your C term, and I'm going to tell you how the C term transforms your parent function. Okay, the C term moves it up or down. Okay, so here we have 2x squared. So what did this 2 do to the parent function, Jathan?
Repeat that, please.
What did the 2 do to the parent function?
Everything. Made it narrower.
Made it skinnier. Well, now, not only was it made skinnier, this positive 3 is going to move it up 3 spaces on the graph. Does that make sense? Okay, so let's take a look at it here. There it is. Okay, so here's our parent function, you guys. Again, nothing to write, but we're looking and listening. But if you want to draw this in your notes somehow using 2 different colored markers, that's fine. Here's our parent function, and here's the transformation that took place. So the 2, the A value, made it skinnier. Well, obviously the blue is skinnier, right? And then the positive 3 moved the parent function up 1, 2, 3 spaces. Easy point on my unit exam. Any questions about that? So if this said -3, what would happen? Down to 3. Okay? Moving on. Any questions? So I have to erase what we have over here, okay, so that we can see these graphs clearly. Nothing to write. We're looking and listening, okay? Attention. All right, so here's our original. Our f of x, our parent function, plus 3. And you can see 1, 2, 3, it went up 3 spaces from there. Didn't change in shape or direction, just moved up 3 spaces, right? What about -4? It went down 1, 2, 3, and 4, okay? And now here, we have 3x plus 2. Well, it made it skinnier, and it moved it up 2 spaces, okay? I'm just trying to show you how these transformations happen. Now, here's our original. So let me ask the class, okay? That's the original parent function. So, you guys, what does this 2 do to the parent function? Makes it skinnier, okay? Now, Nick, what does this function do to that parent function, to the original? It does what and what?
Make it skinnier.
Yep.
Mm-hmm.
And?
And wider.
Oh, not sure. Okay, anyone else? Yes.
Oh.
And it would move it down. Okay, but what if I did this, you guys? Sam, what would happen if I did that? What if I put a negative there?
It'll be fine.
Flip it down, right? Make it a frowny face. So it would flip it down, make it skinnier, and then move it down 2 spaces on the y-axis. Are you guys getting this? What about this one?
Wider, it'll be wider.
It would make it wider, and then what would happen to it? It would
Go up.
2 spaces. Okay, one more transformation we need to learn, you guys. But you know what? Let's have some EOC practice. So, Josh, which one of these functions, okay, represents what you see here? Everyone should be looking. Again, no math. We're just looking and vocabulary and knowing. Well, let me ask you this. What two options can we automatically eliminate, Josh? Yep. Is that a smiley face or a frowny face? D. Okay, so now we're looking at B or C. Okay, so which one is going to be the one that represents that graph? Correct. Okay, so think of that parent function, which would be this, right? Here's the parent function. Okay, and what happens to it? Well, we flipped it upside down. And what did the fraction do? It made it wider. And then what did the positive 5 do? It moved it up 1, 2, 3, 4, 5 spaces. Okay? So clearly, you know what? Knowing just the smiley face and frowny face situation gave you a 50% better chance of answering that correctly. So let's look at this one. What is F, G, H, or J? Jace. What is the correct graph? This one, which one of these four represents this function right here?
H.
Yes. Okay. So the negative flipped it down, right? The 3 made it skinnier, and the positive 1 moved it up 1 space. How are we doing? Yes.
How do you know the 3 made it skinnier?
Because when it's a whole number, it makes it more narrow, and when it's a fraction, it makes it wider. Okay, so let's move on to our last transformation. You guys might need to write this down. Or, however you think it would be helpful for you. Okay, last transformation. So you guys, g of x, we're totally fine. What would be the parent function? G of x equals x squared. Well, this is the parent function where nothing happened to it. But what is happening to this parent function now? We're subtracting 2 from it. We still have the x and we still have the squared, but we're subtracting 2 from that parent function. Everyone put the star, okay? This is another one of those opposite situations that, unfortunately, I hate saying this because I believe in understanding and not memorization, okay? If you were to just look at this negative 2 here, right? And I said, well, negative 2 is being, 2 is being subtracted from that parent function on the x-axis, right? Would you think that the parent function would go to the left into the negative, or do you think it would go to the right into the positive? What would you think? Naturally, since it says negative 2, you'd think it would go to the left. But this is the opposite. Everyone write opposite. Okay? Look what happened here. Here's our parent function. This red parabola represents g of x equals x minus 2 squared. When it's a negative, when you're subtracting from the original, it moves it 2 spaces to the right. So it's the opposite of what you might think. Okay? And then look at this x plus 1, right? Well, here the blue is the original, and then the red, even though that's a positive 1, we went 1 space to the left. Okay? So what if I said negative 1/3 plus 2? Oh my goodness. What if we did all of that? Which is what you're going to get, right? So we had to move it 1 space to the left. What would this negative 1/3 do to it? It would flip it down, right, and make it wider. And then this positive 2 would flip it down and make it wider. Okay? And then this positive 2 would move it up 1, 2 spaces. Okay, just by adding that. Are we getting this?
Mm-hmm.
Okay. So let's try one more. And that's basically it for transformations, you guys. Here's another example where you had the -3. So we moved 1, 2, 3 spaces to the right. And then we had the +2 and it moved it up 2 spaces. Okay? And here we have x plus 3. So we went 1, 2, 3 spaces to the right and down 1 because the C term said -1. All right? So let's look at this. I want you to try it. Okay? So, Catherine, what's happening to our original parabola when we have this +2 and +3 here? What happens? Here's our original. What does this +2 mean? It's going to do the opposite. It's going to go 2 spaces to the left. 1, 2. Okay? So here, this is where we are right now. I should put that in blue. Okay? And now what does this +3 mean? It's going to go up 3 from there. So 1, 2, 3. Okay? And there you go. Perfect. And let's do the last one. Okay? You guys, in your assignment, it's going to say graph, but you don't have to. I just want you to tell me what is happening to the original parent function. Here's our original again. So, Morgan, what's happening to our original parent function here? What and then what?
I don't know.
Okay, Mr. Green?
Yo, it's gonna be
What and then
it's
what?
gonna be down. It's gonna be
Okay.
down since it's a negative.
1, 2. Okay, which one takes it down?
One over there by itself.
Okay, on the right?
Yeah.
Yeah, this moves it down. 2, 3, and 4. Okay, so here we are now. And then what will this -4 do to it? To where we are?
-4. Oh, shoot.
John Treese?
Moves it? Does it move it to the side?
Yeah, which direction?
Left.
No, we do the opposite.
Oh, right.
1, 2, 3, 4. And here you are. Okay? That's it, you guys. That's a wrap. Thank you, Mr. Green.
Yes, ma'am.
Okay, sure.
All right.